Okay, in lab 7, we're going to be looking at the refraction of light. In this lab, you're going to be examining Snell's law. So just remember that Snell's law is a law that relates the index of refraction and the angle of incidence of the material that light is incident in to the angle of refraction. And the formula is the index of refraction of the material that the light is incident in, Ni, times sine of the angle of incidence equals the N of the refractive substance times sine of the angle of refraction. So in this particular lab, you're going to be looking at a block of acrylic material, and you are going to measure angles of incidences and resulting angles of refractions. So the way you're going to do that is you're going to add the compass, and you're going to move the compass so that the center of the compass is at the center of the angle of refraction. So if you press play on the video, you'll get, the laser is going to be entering the substance from up top in air, and then it's going to enter into the new substance. So you're going to position the protractor just like it is in this image. The angle of incidence is always measured with a normal line. So the normal line is perpendicular. It's an imaginary line that's perpendicular to the surface that it's entering. So I'm basically going to start from the zero point here, and I'm going to measure to the incident ray. It looks like the angle of incidence is 45 degrees. The resulting angle of refraction in the material, I'm going to do the exact same thing on the bottom. I'm going to start with a 0 and measure out to that refracted ray, and that looks like it's 30. Actually, it looks like it's 29 degrees. So we're an angle of incidence of and you can actually zoom in if you need to see this bigger, but it looks like the angle of incidence is 45 degrees, and the angle of refraction is not quite 30, looks like it's 28 degrees. And that's what you're going to be doing to collect data. And as you play the video, you can stop it and change the angle of incidence and measure the angle of refraction. So you will be plotting angle of incidence and angle of refraction. And the angle of incidence, since you're controlling that, is your independent variable, and you're measuring the response of the angle of refraction, so that's your dependent variable. So I is the independent variable, and angle of refraction is your dependent variable. All right, so you will be making a column that has I in it, and we'll just actually angle of incidence, and the variable will be I, and you'll have the angle of refraction, units are degrees, and the variable is R. And so, for example, you would have 45 degrees and 28 degrees as your first point. Now, if you just plot angle of incidence versus angle of refraction, you can get some kind of weird graph. It may look somewhat linear, but it's really not the right relationship, because it's really the relationship between sine of these two things. So to determine the sine, I'm going to click on this 3 buttons. I'm going to insert something to the right. I'm going to put in the name is sine of I. There are no units to this, and the variable will just be sine of I. And I'm going to click on the 3 dots, and I'm going to change the formula, and I'm going to put sine of the angle of incidence. Submit. So it tells me the formula is not valid, So I need to actually change that to be equal sine of I in parentheses equals. Okay, so I'm going to find sine of I, I'm going to in parentheses, and then I'm going to press submit. So you have to make sure you put both parentheses in there. All right, so it's taken the sine of I. Now I'm going to do the same thing for angle of refraction. I'm going to click on these three dots. Going to insert to the right. I'm going to call this sine of R, and this will be sine of R for the variable. And then I'm just going to I'm going to go sine of the angle of refraction and in parentheses and submit. And you're going to want to get at least 10 points. Okay, you want to get at least 10 points. Then you're going to want to make a graph of sine of I versus sine of R. And I'm just going to put another point in here so we can just get a couple points on the graph. I'm just making this up. And then I'm going to insert a linear fit. Okay, and so look at this. Sine of I equals A times sine of R. And A is going to be the index of refraction of this material. And so remember that if we go back to our original formula, Snell's law is Ni sine of I equals Nr sine of R. And Ni is the index of refraction for air, which is 1, so that actually just kind of goes away because it's 1. So this really turns into sine of I equals Nr times sine of R. So when you look at that linear fit, that is the exact same equation, right? So this slope is going to be your index of refraction. Now, if for some reason you put sine of R on the y-axis and sine of I on the x-axis, then the slope will be the inverse of that. So whatever 1 over 1.5 is what the slope would be of this graph. Okay. So I'm going to be looking to see that you insert a linear fit and that you're using your curve fit to help determine that index of refraction. And that's basically it.